Hi, don't forget to check out my course for the Quant section of the CAT exam, where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail. Hey everyone, this is the next question from CAT 23, the third slot. Please pause the video and try solving it first, and then you can resume for the solution. So the question says, for some real numbers a and b, the system of equations x plus y is equal to 4 and a plus 5 into x plus b square minus 15 into y is 8b has infinitely many solutions for x and y, then the maximum possible value of ab is. Okay, very beautiful question. There are multiple concepts involved. And this is one question which I do in the class also, in my lecture also, every time I discuss this particular chapter. So let's see how we deal with this. So the first thing we need to understand to solve this question is, guys, whenever we have two linear equations of the form a1x plus b1y plus c1 is equal to 0 and another linear equation a2x plus b2y plus c2 is equal to 0. It's not y1, it is y actually above. When I have these two linear equations, whenever the ratio of the x coefficients, that is a1 upon a2, the ratio of the y coefficients, that is b1 upon b2, and the ratio of the constant terms, c1 upon c2, are all equal, only then we can say that the two straight lines have infinitely many solutions, right? So these two equations will have infinitely many solutions when the ratio of the x coefficients will be equal to the ratio of the y coefficients, which will be same as the ratio of the constant terms. So now in this question, the equations are 1x plus 1y minus 4 is 0. I'll take the 4 on the left hand side here. And the other equation is a plus 5 into x plus b square minus 15 into y. And I take the 8b on the left hand side, so minus 8b should be 0. We know that the ratio of the x coefficients, y coefficients and the constant term should be equal. So the ratio of the x coefficients here is 1 upon a plus 5. So I'll write it here, 1 upon a plus 5. The ratio of the y coefficients here is 1 upon b square minus 15. And the ratio of the constant terms is minus 4 divided by minus 8b. So as per this concept that we have seen, the ratio of the coefficients should be all equal. Okay, so first step is we cancel out a minus 4 above and below here. Minus 4 gets cancelled above and below. Here you will have 1 and below you will have 2. So the last part can be changed to 1 upon 2b. And now the next step is I will first equate the first and the last part to get a plus 5 should be equal to 2b, implies that a is actually 2b minus 5. And I observe that this is a linear equation in a and b, does not help me too much right now. But now the important part comes in when we equate the second and the third part. So I equate this part with this part. I will get 1 upon b square minus 15 is 1 upon 2b. That is, b square minus 15 should be equal to 2b. So b square minus 15 is equal to 2b, or b square minus 2b minus 15 is equal to 0. Well, this is a quadratic equation which can be factorized as b minus 5 into b plus 3 is equal to 0, which finally gives me b is equal to 5 or b is equal to minus 3. Right? So this is where the real beauty of the question lies. The question is asking you the maximum possible value of AB. So people assume that A and B will be positive and then they ignore the value B is equal to minus 3 and consider only B is equal to 5 and they end up getting the wrong answer. I'll show you how. But that's a mistake we have to avoid at all costs, guys. The question is asking you to maximize A into B, the product A into B. So A and B can be individually both negative also, as long as the product will be maximum. So we have to consider both the possibilities and don't ignore any possible case here. Okay. So let's see further. We know that A is 2b minus 5. So if B is equal to 5, A will be 2 into 5 minus 5. So 2 5s are 10 minus 5 will be 5 only. In this case, the product of A and B will be 5 into 5, that is 25. And we have seen this value in the options. As I've said previously, many people fell for the trap and they marked option D as the answer. But the interesting part comes now. When I take B as minus 3 and put in the given equation for A, I get A as twice of minus 3 minus 5. That's minus 6 minus 5 or minus 11. Now, although A and B are both negative, the product minus 11 into minus 3 is plus 33. That is your answer. The maximum value of the product A into B is the option B, 33. Very deadly trap towards the end of the question. Very beautiful question. And that's how, with great concentration and with great patience, we solve this question. The correct answer is option B and not D.